Okay, so welcome back to Unit 3, and we're doing combination lesson of 3.1 and 3.2. Basically, we're combining all of the parts that we learned in our last video together in a sort of chart format to summarize our understanding. So right now, if we look at the first example here, we've got factored form that's given to us. I know that it's in factored form because I see my two brackets there, which represent my x-intercepts, which are my r and s value. It's going to ask me to turn it into standard form, find the zeros, which comes from my factored form, the axis of symmetry, which is the midpoint between my zeros, my max or min value, which is referring to the y value of the vertex, which comes from my axis of symmetry, the y-intercept, which is coming from my standard form, or when x is equal to 0 in my vertex form, and then ultimately putting together my axis of symmetry and my max and min value to produce a vertex. So we're going to start off by first expanding this factored form and turning it into standard form. We'll use our FOIL method to expand. So x times x times 4, negative 1 times x, negative 1 times 4. We'll collect the like terms. And so right now we can see side by side our standard form and our factored form. The next part is asking me for my zeros. In order to do the zeros, again, we will use our factored form, separate our two brackets and make them equal to 0. So x minus 1 equals 0. This becomes positive 1. X plus 4 equals 0. This becomes negative 4. Again, we did this in our last lesson on the other video, where we're just taking the negative 1 and bringing it over, it becomes positive. Taking the positive 4, bringing it over, it becomes negative. Now we're looking at our axis of symmetry, which is our midpoint equation that we learned from the first unit or first lesson. So that's r plus s divided by 2. So we'll do 1 plus negative 4 divided by 2. And we're going to get a not so nice number of negative 1.5, which is my x value in my vertex. So already I can come over to the vertex and fill in what my x value is, negative 1.5. Now we got to figure out the y value of the vertex. The y value of the vertex, well, we know what our x value of our vertex is. So we'll go back to the original equation which was given, which is this fx equals x minus 1 and x plus 4. And we'll replace our x value to solve for our y. So negative 1.5 minus 1, negative 1.5 plus 4. Type that into our calculator and solve. This is ultimately going to be a negative 2.5 multiplied by a positive 2.5, which will be negative 6.25. So that's what my y value is in my vertex. I'll go fill that in. And then for my last part here, the y-intercept. The y-intercept, you can do this two ways, by replacing x with 0. So here I replaced it with negative 1.5. If you want, we can replace it with 0 and solve, because that's where the y-intercept happens. Or we can look at our standard form equation, and we know that in our standard form we have our a value, which is important, and we also have our c value, which represents our y-intercept. So if I were to plug in a 0, I would solve, and it would eventually be a negative 4. So my y-intercept is negative 4. So now looking at this next example which is given to you, it's very similar to our factored form example that we did for A. So I would want you to do this example on your own and then check the note for the solution. So right now I'm going to look at another example, which is if I give you something in standard form. So I've given you standard form and now we have to turn it into factored form. So I'm going to come over and write in what my original standard form equation was. And then I'm going to determine the forms of factoring that I can use. So the first form of factoring that I should always try is greatest common factor. And what we can see that we can take out is, of course, that -1. That -1 can't be at the front. So no matter what, we're going to take out that negative sign. I know that it's a 1 because the lowest value with that x squared is a 1. So that's what I'm taking out. And there's no variable that I can pull out of this equation. The 16 has no x with it. So all I can take out is that -1. So we'll start with that. You take that -1 out, and then your expression becomes x squared plus 6x minus 16. From this, we can see that we've got a trinomial inside my bracket, which is actually a simple trinomial because the x squared has a 1 in front. So we'll use sum and product to find out what the two numbers are that make a +6 and a -16. Those two numbers in my product will be an 8 and a 2. Then to determine which one has the sign, we'll take the sign of the sum and write it with the bigger number, which means that my 2 is a negative. So we'll come back down. We'll put our two brackets. And we'll write in what our values are that we solved that satisfy the sum and product, which is a +8 and a -2. Now we'll continue filling in our chart, which is asking us for the zeros. So for the zeros, we're going to look at our factored form, and we'll bring over what our two factors were, which was x plus 8. So we have one x-intercept at -8, and then we have x minus 2, which our next x-intercept would be at +2. Our next section is asking us to solve for our x value of our vertex, which is our equation of the axis of symmetry, which is our midpoint. So r plus s divided by 2. Our r and our s, which we solved for, is a -8 and a +2, which will become a midpoint or an x value of -3. This is the x value of the vertex. So I can go over to the last column and fill in what my x value of my vertex is. And now we'll solve for the y value of the vertex. In order to solve for the y value, you know what the x is. So we'll use the equation that's given. So the equation that was given to me was this -x² minus 6x plus 16. And we'll replace the x value with a -3. And we have to be careful with our double signs. So when we type that into our calculator, we have a negative sign with a bracket, and then our x value is a -3 squared minus 6, and then the x value again is a -3 plus 16. So be careful when you type this into your calculator with the double negatives. Do not just think that those two negative signs equal a positive, because they do not. And our answer ends up being 25 when we type that into our calculator. Our next part that we'll need to figure out, sorry, we'll just write that in too. We'll write in our y value for our vertex, which is 25. Our next part that we have to figure out is the y-intercept. So the y-intercept comes from my standard form, or subbing in an x value of 0. So there's my c value, which is my y-intercept. So we can go over and write in that our y-intercept is positive 16. The last example that I've given you is 16x squared minus 9. I'd like you to try this one on your own to fill in these columns. So you'd have to first factor it and then fill in the rest. Make sure that you check the note which is posted online. Check the filled in version to ensure that your answers are correct. Okay, right now we're going to be getting into some word problems and some graphing. So if we look at our first question here, we have the height h in meters of an infield fly ball given in t seconds after the ball is hit, which is represented by the formula the height is equal to 30 multiplied by the time minus 5 times squared. So if I look at this equation already, I can see that it looks kind of funky to me. It looks like it's out of order. So for me, I know in grade 11 mixed that my quadratic should always be written from my highest degree to my lowest. So already I'm going to rewrite this. And I'm going to write it in the form negative 5 t squared plus 30 t. Now looking at this question, it's going to ask me how long is the ball in the air. So ultimately it's this parabola of a ball going up and coming down. And time is always represented on my x-axis. So it wants to know how long this ball is in the air for, which is asking me to solve for my two x-intercepts. So in order to solve for my two x-intercepts, I'm going to factor and then set those factors equal to 0 for my y value because the ball is on the ground when the height is at 0. So in order to factor, the first form of factoring that we're going to use is called greatest common factor. I know that I can't have that negative sign, so I'm going to take out a negative. And then I'm going to try to take out a 5. Can a 5 divide evenly into that 30? Yes, it can. So then 5 is the greatest common factor for my coefficients. Then I'm going to look at my variables. I've got 2 t's with my first term and 1 t with my second. So therefore I can only take out 1 t. Then I'm going to write that greatest common factor at the front and reduce my quadratic by negative 5t. So negative 5 divided by negative 5 is positive 1. You had 2 t's, you took 1 away, so 1t. Then the next part, positive 30 divided by negative 5 ends up being negative 6. Now I look inside my bracket. Can I use any other forms of factoring? Is it a trinomial, or are there 3 terms to be able to use sum and product or decomposition? No. Could it be a difference of squares? Maybe. Let's see, I've got 2 terms. I've got a t minus 6, so there is a minus sign, but can I square root a t? And can I square root a 6? No. So if I can't square root them, then it is not a difference of squares, and then I'm done factoring. So in order to solve for this problem, it's still asking me what or how long the ball was in the air for. So the first, I'm going to separate and set them equal to 0. So negative 5t equals 0. 1, or t, I don't need to write that 1 there, minus 6 is equal to 0. We'll divide by negative 5. T is equal to 0. So the ball is starting at 0, at the height of 0. And then the ball goes up in the air and hits the ground after 6 seconds. So then I would write a therefore statement. Therefore the ball is in the air for 6 seconds. And now my next question is asking me to find out what was the maximum height of the ball. Well, we know that the maximum height occurs in between our two x-intercepts. So when the ball was first hit to when it landed. So I'll start off by solving for the x value, or the midpoint between my two zeros. So 0 plus 6 divided by 2 ends up being at 3 seconds. That's when the ball has reached its maximum height. This is when it's occurred. What is the maximum height? Well, I'm going to need to go back to my original equation. And I can go all the way back to the formula that was given to me in the question because I know that one is correct. So my time, 30t minus 5t squared. And we'll replace t with 3 seconds. Type that into our calculator to solve, and we'll end up with 45. So when does it occur? The vertex is at 3 and 45. And for us, 45 carries a meaning, and 3 carries a meaning or a unit with it. The 3 is 3 seconds, and 45 is in meters. So 45 meters. So just as a quick recap of what we did in this question, we're basically understanding that with our word problems, if we want to, or if we ever see the words how long the ball is in the air for, or what is the time that the item is floating or above the ground, it is always asking me to factor and to find the x-intercepts. If the question is ever asking me what is the maximum or minimum value, these questions are asking me to solve for the midpoint, and then use that midpoint to solve for, or to input into our equation to solve for the y value of our vertex. So right now we're going to work on graphing. And in this unit, we're basically going to be doing sketches that are a little bit more accurate than our our second unit. So right now, to make this sketch more accurate, I'm going to be asking you to find the zeros, the vertex, and the y-intercept. Right now, the formula is given to you in standard form. In order to find the zeros for our first step, the zeros means the x-intercepts or the roots. So we'll start off by factoring. X squared minus 3x minus 4. This is a trinomial, a simple trinomial that we can use sum and product for. So two numbers that multiply to give me 4, add together to give me negative 3, will be 4 multiplied by 1. I'll take the sign of the sum and put it with the bigger number. So negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. Now we can rewrite our equation. Y equals x minus 4 and x plus 1. But of course we're not done there because we actually need to solve for our zeros, which means separate and set them equal to 0. So we'll take that negative 4 and it becomes positive 4, and that positive 1 becomes negative 1. These are my two zeros of my quadratic. The next part that it's asking me to solve for is the vertex. So in order to solve for the vertex, we're going to need first the midpoint. So we'll solve for the vertex by first solving for the midpoint, where we take our two x-intercepts, 4 and -1, add them together and divide by 2. So we'll end up with 1.5. In order to solve for the y value of the vertex, we'll need to replace our equation, our original equation, with 1.5 to be able to solve for its y value. So I'm going to use the x squared minus 3x minus 4, 1.5 squared minus 3 times 1.5 minus 4, and we'll end up with a y value for our vertex of -6.2. The last part, the third thing that it was asking me for, was the y-intercept. For that, all I'm going to do is look at my standard form, circle the last number, and this will be the third part that it's asking me for, the y-intercept. Because if I made x 0, and a 0, and they cancel out, I'll be left with -4 for my y-intercept. So now we're going to go over to our graph paper, and we'll do a quick sketch. So my two x-intercepts are at 4, 1, 2, 3, 4, and at -1, and I'll put 2 dots to represent the x-intercepts. My midpoint is occurring at 1.5, and that's reaching a y value of -6.25. So 1, 2, 3, 4, 5, 6, 6.25. So I'll say that -6.25, somewhere around there. Now if I look at this parabola, if there's my vertex at -6.25 and 1.5, this parabola should be pointed up if it has to pass through those x-intercepts. And if I go back and look at my equation, the a value in the front is a +1. So it is pointed upwards. And the sketch that I would do for my vertex would show arrows coming from my vertex, going up, crossing my x-intercepts at -1 and 4. And that's how we're going to be graphing or sketching in this unit. The last example that we're going to work on together is a more complicated word problem. A ball is thrown off a 180-meter cliff. The relation in height is given by the formula -5t squared minus 5t plus 180. It gives the approximate model of the height of the ball, h in meters and t time in seconds after it's thrown. Now here's the tricky part. How long does it take the ball to reach a ledge 80 meters from the base of the cliff? So what it's telling me to do is to find how long the time, t, it takes when the height is already at 80 meters. So this means I need to replace my h with 80 and then solve. So first, I'm going to write down my formula, which is h 5t squared minus 5t plus 180. And now this 80 meters, which was given to me, I can't just ignore. It's not asking me when the ball hits the ground. So when the ball hits the ground means that this height is at 0. But right now our height isn't at 0. It's at 80. So we're going to have to replace that height with 80 and then begin solving. But in order to solve, I have to set this to 0. It can't be an 80 there because the only way to factor is when I'm factoring to solve for the x-intercepts at 0. So we're going to have to take this 80 and bring it over so that now I have a 0. When I take that 80 and bring it over, of course it used to be a positive 80 and now it's a negative 80. I'll collect like terms. So I'll group the 180 and the 80 together. So now I end up with 5t squared minus 5t plus 100. And then I can begin my steps to solve. Remember, when the question is asking you to solve for anything, just if you see those words, how long it takes, which is time, or how to solve for the equation, which is the x-intercepts, which is represented by time, you're always going to be doing the same thing of factoring. Now, I need to solve for the midpoint and ultimately the height if it's asking me for the max or min value. This question is not asking me for the max or min. It's saying how long does it take, which is time, which is x, which are my x-intercepts. So I'm going to start off by factoring. In order to factor this, I'm going to take out a negative 5 first. So that we'll be left with a simple trinomial, t squared. The negative 5 divided by negative 5 ends up being positive t. Then 100 divided by negative 5 is negative 20. So now I can use sum and product to be able to solve for positive 1 and negative 20. Two numbers that multiply to give me 20 are 5 and 4. I'll give the sign of the sum to the bigger number. That means that my 4 is a negative to satisfy my sum and product. We can then go back to our equation and finish factoring. The negative 5 stays. You have your two brackets with t or x. I dislike using t because it looks like a plus sign for me. So t, and then the two numbers are positive 5 and negative 4. Now we know we're asked to solve for the zeros. So after we've turned it into factored form, we'll take these two values and we'll set them equal to 0 and solve. Now when we solve, we're going to notice something weird. There'll always be a correct answer that we'll use and an incorrect answer that it's not that it's incorrect, it can't exist in the real world. So when this ball is at 80 meters high, it's taken a certain amount of time to reach that 80-meter height after being thrown off of a cliff of 180 meters. So if we look at sort of a picture of this, right, like a graph, we're sitting at 180 meters. And then the ball goes off the cliff. And it's asking me to solve for the time that the ball's at 80 meters. And it's asking me for how long this time is. Well, theoretically, the parabola exists both in positive and negative time. But really, we can only ever have positive time. We can't have this negative time on our left side. So if I look at my answer right now, I've got a negative 5 and a positive 4, which would be the numbers of negative time, negative 5, and positive 4 for my time. Which answer am I going to select or answer the question with? The positive 4. Because negative 5 cannot exist. So I'll write my therefore statement. Therefore, the time of the ball at 80 meters is 4 seconds. Now on the last page, I have two final examples 5 and 6 that really repeat some examples that you need to know how to do from the first video and the second video. So that's me giving you a graph and determining the equation in factored form and then turning it into standard form. So I want you to practice example 5 and example 6 of a ball being kicked up into the air on your own, and then to look at the solutions page for the answers to check your work.